Ferrari has just revealed why its radical Spa wing could become the most important aerodynamic weapon of the season. The so-called Macarena wing rotates its upper flap through roughly 270 degrees, completes the transition within 400 milliseconds, and has been estimated to add between 8 and 10 kilometers per hour in the right conditions. The FIA has already inspected and approved the system. Ferrari has already won with the latest upgrade package, and now Spa will expose whether the concept is even more powerful than rivals feared. But the real breakthrough is not simply higher top speed. Ferrari may have found a way to carry more downforce through the corners, remove much of the drag on the straights, and protect the tires at the same time. If that balance is real, Mercedes and Red Bull are not chasing one unusual wing. They are chasing an entirely new way to build a Formula One car. Subscribe to the channel. To understand why Ferrari's Macarena wing has become such a serious threat, you first have to understand the impossible compromise Spa forces on every Formula One team. Spa is not one type of circuit, it is several circuits trapped inside one lap. The car needs stability through high-speed corners. It needs traction through slower sections. It needs confidence under heavy braking. And then almost immediately, it needs the smallest possible amount of drag on one of the most important straights of the season. That creates a problem. More rear wing gives the driver more grip, but more rear wing also slows the car in a straight line. Less rear wing improves top speed, but it makes the car more nervous when the driver needs confidence most. For decades, teams have accepted that compromise. Ferrari is trying to destroy it. The Macarena wing is designed to give the car two completely different aerodynamic personalities during the same lap. In the corners, the upper flap remains in a position that helps create rear downforce. That load pushes the tires into the circuit. It gives the driver more stability. It helps the car rotate. It improves traction. Then, when the Ferrari reaches the straight, the upper element rotates through roughly 270 degrees. The flap moves into an extreme low drag position. The sponsor logo can appear upside down. The rear wing stops behaving like a traditional wing, and the car begins shedding resistance far more aggressively. That movement is what created the nickname. Fred Vasseur compared it to the Macarena dance because the flap appears to twist and flip through the air. It is funny to watch. The performance target is not funny at all. Paddock estimates have suggested the device may be worth between 8 and 10 kilometers per hour in certain conditions. Ferrari has not publicly confirmed the true gain, and that matters, because teams almost never reveal the exact value of their strongest ideas. If the gain is enormous, Ferrari does not want rivals to know how urgently they need to respond. If the gain changes depending on setup, wind, temperature, or electrical deployment, one public number could be misleading. So Ferrari keeps the real data hidden. But Spa is about to reveal clues. The speed trap will show the maximum velocity. The acceleration trace will show how quickly the car builds speed. The sector times will show whether Ferrari is gaining only on the straight or across the entire lap. And that final point is the most important, because the true advantage may not be the top speed number. It may be the freedom Ferrari gains before the straight even begins. Imagine two cars reaching Kemmel at the same speed. One car had to run very little wing to achieve it. That car is weak through the corners. The driver struggles with rear grip. The tires slide. The car loses time before it reaches the straight. The second car runs more downforce, is stronger in the corners. Then the active rear wing rotates, removes much of the drag, and allows the car to reach the same top speed. The speed trap shows equality. The lap time shows domination. That is what Ferrari may have discovered. Not simply a faster straight line mode. A way to reduce the traditional penalty for running more downforce. And at Spa, that could be devastating. The climb through Eau Rouge and Rydillon demands confidence. The driver cannot hesitate. The car compresses. The load changes. The steering input must remain precise. Any instability through that sequence damages the exit, and a poor exit destroys the entire run along Kemmel. Ferrari's system could help at both ends of that sequence. More downforce may improve the climb. Then the rotating flap may reduce the drag immediately afterward. Better corner performance, better straight line speed. One system connecting both. That is why Mercedes and Red Bull will not only watch the speed trap, they will study Ferrari's minimum speed through the high-speed corners. If Charles Leclerc and Lewis Hamilton carry more speed through the difficult sections, then remain competitive on Kemmel, the Macarena wing is doing something much more valuable than the headline suggests. Is changing the setup window. That means Ferrari can approach the weekend differently. Other teams may be forced to remove downforce to protect their straight-line speed. Ferrari may be able to keep more wing. That could improve braking stability, mid-corner grip, traction, tire life, and confidence in changing conditions. Spa often creates uncertainty. The weather can shift quickly. One section of the circuit may be wet while another remains dry. Wind can disturb the car at high speed. Temperatures can change the tire behavior. A car with a wider aerodynamic operating window becomes easier to manage. And Ferrari has repeatedly described its technical goal in exactly those terms. A broader balance range, more performance across the complete operating envelope. Those phrases sound cautious. They reveal the real target. Ferrari does not want a wing that produces one spectacular speed trap number. It wants a system that makes the entire car more usable. That is a much harder challenge. A rear wing affects almost every phase of a lap. Under braking, it helps stabilize the rear. During turn-in, it influences the balance between the front and back of the car. At the apex, it affects how much speed the driver can carry. On corner exit, it helps the rear tires transmit power to the track. Change the wing, and all of those behaviors change. Now imagine changing that wing position repeatedly during every lap. The front active aerodynamics must react with it. The rear must not lose load too suddenly. The front must not remain overloaded. The center of aerodynamic pressure must stay within a predictable range. And the driver must trust the transition every single time. That is why the 400 millisecond timing requirement is so important. The FIA does not simply care whether the wing opens. It cares how quickly the system moves between its two legal states. Ferrari's design was inspected directly at Maranello. The FIA confirmed that the opening and closing sequence complied with the required timing window. That approval removed the most obvious threat to the concept. The device is not currently facing an official illegality ruling. There is no confirmed protest that has removed it. The dramatic movement may look like Ferrari is exploiting a loophole, but the system passed inspection, and that makes it more dangerous. A questionable advantage can disappear through regulation. A legal advantage forces rivals to spend money, time, and engineering resources trying to match it. Red Bull has already shown a similar rotating wing idea. That immediately created online accusations that one team had copied the other. But there is no confirmed evidence proving design theft. Two teams can study the same regulations and reach a similar conclusion. The important point is not who thought of it first. The important point is that another top team believes the concept is worth pursuing. That tells us Ferrari's interpretation is not being dismissed as a novelty, is being treated as a serious technical direction. But two wings that look similar can perform very differently. The exact rotation angle matters. The profile of the upper flap matters. The main plane matters. The stiffness of the structure matters. The actuator position matters. The timing software matters. The relationship with the front wing matters. And the way the rear wing interacts with the diffuser may matter most of all. A photograph can show the movement. It cannot reveal the pressure map. It cannot reveal how the airflow separates. It cannot reveal how smoothly the load disappears. It cannot reveal how the diffuser behaves when the upper flap rotates. That is where Ferrari's hidden data becomes valuable. The rear wing does not operate in isolation. It influences the pressure behind the car. That pressure affects how effectively the diffuser extracts air from underneath the floor. Change the rear wing state, and the diffuser may experience a different aerodynamic environment. If Ferrari has managed that relationship correctly, the total drag reduction could be greater than the visible wing movement suggests. But if the pressure changes too aggressively, the car may become unstable. That is why Ferrari did not immediately use the system everywhere. The wing appeared during pre-season testing in Bahrain. It attracted attention instantly, but Ferrari introduced it slowly. It ran during first practice in China. Then the team removed it before qualifying. Fred Vasseur explained that Ferrari had not completed enough mileage. That was a revealing decision. The engineers were not questioning the idea. They were questioning whether the system was ready to be trusted. A moving aerodynamic element must survive enormous stress. At high speed, the forces on the rear wing are severe. The mechanism must rotate while loaded. It must reach the correct position. It must lock into place. Then it must return before the next corner. And it must repeat that process without hesitation. One failed activation could cost lap time. A more serious failure could affect the balance before a fast corner. That risk explains the cautious rollout. Ferrari needed data, heat cycles, vibration data, repeated activations, different speeds, different fuel loads, different track surfaces. The system returned during a filming day at Monza. That circuit was a logical testing ground. Long straights, high speeds, low drag demands, a perfect environment to study whether the mechanism remains stable and whether the car gains speed as expected. Then came Miami. Ferrari introduced a major package containing 11 separate updates, and Vasseur confirmed that the Macarena wing would remain on the car from that point forward. That statement changed the status of the concept. It was no longer an experiment. It had become part of Ferrari's permanent aerodynamic strategy. And once a team commits to a concept, the development accelerates. The first version proves the idea. The next version improves the reliability. The next improves the performance. The next adapts it to a particular circuit. That is exactly why Spa matters. Ferrari has already moved beyond asking whether the wing can work. Now it is asking how far the system can be pushed. The latest expected version is described as more aggressive. The source does not confirm the exact shape or internal changes, but a more aggressive configuration could mean a larger low drag opening, a different flap profile, a more extreme final angle, or a revised interaction between the rear wing, diffuser, and exhaust flow. Any of those changes could increase straight line efficiency, but they could also increase the difficulty of controlling the transition. The bigger the difference between corner mode and straight mode, the greater the potential gain, and the greater the risk. Imagine the car carrying a large amount of rear load through a corner. Then that load falls rapidly as the flap rotates. If the front wing changes at the wrong rate, the balance can shift. If the rear unloads too quickly, the driver may feel the back of the car become light. If the flap does not return smoothly before braking, the driver may enter the corner with less stability than expected. This is not simply a mechanical movement. It is a controlled aerodynamic transformation. The Ferrari becomes one car for the corner, then another for the straight, and it completes that transformation in less than half a second. That requires precise coordination, software, sensors, electro-hydraulic actuators, wing position feedback, front-to-rear balance maps, energy deployment, driver input. Everything must communicate. One delay can disturb the whole system, and Spa will punish any weakness. The speeds are high.